Hey everybody, today we're going to be building a fun text-only game prototype channeling Jeopardy, the popular TV game show, in just HTML, CSS, and JavaScript. I hope you'll find this video to be a fun exercise for building a prototype of a game very quickly using only the basics. Here's what we're going to be building today. You can see on the screen I've got a Jeopardy-ish layout. We have a title and a score. It starts at 0. And then I've got a few different categories here. These categories have come to us through an API we'll talk through in a second. I can click on a clue, so I'll take video games for 200, and then a prompt is revealed. This one says a Ford Escort can race a W Beetle, an A-spec PlayStation racing game with over 150 cars, and I get a chance to type in the answer here. I actually don't know this. It's like, not Forza, I don't know. But if I submit the answer, it's gonna tell me I was incorrect. It was actually looking for Gran Turismo. If I was correct, like this one, the red species of this canine means most anything except perhaps sour grapes. Fox? Yes, if I was. If you are correct, you get correct prompt, and then the score of that clue is added to the score up top. And you can keep answering these until all the clues on the board are gone. Hey, and quick plug before we get started, I make game dev and JavaScript tutorials right here on this YouTube channel. If you're into that kind of thing, please subscribe. So for this tutorial, we're going to be using a public API called JService. The link to this will be in the description below. It's an open source API that has the creators generously uploaded every single question that's been asked on Jeopardy, the TV show. So that's very cool. Very grateful for that. Our app is going to hit this API to dynamically get some of those clues based on categories that we provide. That's only kind of one function of this API that we're going to use, but you can see that you can do a ton of stuff with it. Now, this API is going to be fine for the sake of this tutorial video. The author does specify this is not actually intended for production use. It's kind of use at your own risk. So if you plan on creating like an actual game show kind of product or something, you're definitely going to want to have your own API. But again, for the sake of this tutorial, this is going to be great. Alrighty, let's get going. So here I am in CodePen. What I've done is created a pen that has some stuff pre-filled for us just to save some time. So I just want to walk through the HTML and CSS part, and then most of what we're going to be doing is JavaScript here. But if I look at just the HTML alone, see I've got this div container, there's only one of them, called app, with the class name of app. In that, there's a header. It's got our headline with Trivia Game Show. You see that over here. And then our place for our score to go. There's a span in here that's currently empty, but this is going to get injected with the actual score count. We'll do that with JavaScript, of course. And then we have a board container, and this is where the clue lists are going to go. It's going to fill kind of the space over here. But again, nothing's happening yet, so it's empty. And then finally, when you click on one of those clues and it brings up the answer question part, that's going to live here in this invisible modal. So in this modal, we have a headline where the clue text gets injected, a form where we have a text input, and then a button to submit the form. That's how the user submits the answer they think the thing is. And then under that, we have a container that has the result. So if you submitted the correct answer, you'll see the correct text, and it's got some classes on here just styling it to make it green or red. Incorrect if you're wrong. And then finally, this paragraph here that gives you the correct answer once you submit your answer. And then to quickly just peek at the CSS, not too much going on in here. I've just got some basic variables for some of the reused colors, like that blue gradient and then that yellow text. And some basic structure stuff. I really pre-filled this just to save time in the video, but it's all linked in the code below in the description, so go ahead and check that out. Taking a look at the JavaScript now, what I've done is pre-filled just a little bit here. We're going to be doing some array shuffling, and so I went ahead and just grabbed a function from Stack Overflow for taking an array and shuffling it, just to not spend time writing that here. And then I'm going to utilize a class to implement this game. And so I've just created the basic structure here where we have a new class called Trivia Game Show, and there's just an empty constructor right now. It's going to take in an element, and it's going to kind of like fill out where the game lives. And so for that, we're going to use our div app here, just the kind of top level div that we have going on. And then it also will accept some options that we'll cover as we go. And so to kick it off, down here, last line of script that's happening is I'm creating a new instance of Trivia Game Show, passing in that app div to be where this thing lives, and then not using any options so far, so it's just an empty object for that second argument. Okay, so the first thing I want to create on this class is use category IDs. And these categories are going to be the Jeopardy categories that we get from the API. And so what we want to do is I want this to be an array of IDs, and what that looks like from the API are numbers. So like, for example, 1892 is a category called video games, and here I'll just paste these in. Did some research ahead of time and found that these provide some nice defaults for us to use. So we've got video games here, 3-letter animals, geography, and science and nature. I've chosen only 4 here just for the screen real estate we're dealing with for the video, but in theory, these are going to be an array, and you can have as many or as little as you want. So I'll go ahead and just plop these in here, 44, 83, 88, and 218. And now these might seem totally random to you. Remember that they came from the JService API. So if you just check out this link right here, which will be in the description below, you can search for whatever categories you want, and that's how I got these specific numbers. So we're going to set up our class here to use these numbers, but right now they're hard-coded right here in the constructor. It'd be nice if we could allow people to pass in whatever categories they want. And so to do that, what we can do is make this an option. So I'll say use category IDs is going to equal options dot use category IDs. But if this isn't present or doesn't exist, then we can go ahead and just say or here, and then we'll fall back to this list that I've created here. And so now when you boot up the app, if you would want, if you went out to the API and found the categories you wanted to use, you could just pass in your own array right here with some numbers, and then the app would use these categories instead of the hard-coded ones that we have here. For simplicity though, I'm not going to utilize that. I'm just going to leave that empty. Alrighty, moving right along. The next thing we're going to add to our constructor here are kind of our database of clues and categories. We've got the IDs here, and those are the IDs we're going to go out and get, but when we actually get them, we need to store them somewhere. So first we'll have an array of categories, and we'll talk through this data structure in a little bit. But for now, we're just going to start with an empty array for categories, and then what we're going to do is make a key value store for every clue that we get back so that each clue can have a unique identifier. We'll make it easy for us to look up the clue that you clicked on and look up the answer to that clue and mark that one as done or whatever. And so that's going to live in this object here that we'll fill out in a minute. The next thing we're going to add are some state variables. And so specifically, I want a reference to the current clue. So that can start null. But say we click on a clue to bring it up in that modal, we need to know which one we clicked on so then we can read data from it and that sort of thing. So this thing will hold that. And then of course we have a score. That'll start as 0. And finally, we're going to have this list of elements. And so we're not using a front-end framework here. This is all just vanilla JavaScript. And so we're going to be in charge of doing the DOM manipulations ourselves. And so what I like to do is just kind of right up front in the constructor, create a reference to all the elements we're going to be interacting with and using. That way we don't have to do any DOM querying later, which can be kind of expensive depending on how often you do it. Oh man, so giving us some more real estate here. I've pasted these in because there's a bunch of them, but basically these are all things that we're going to be tinkering with as we interact with the app here. So board is like the whole container of where the clues are going to go. We've got the score count element. That's the text label up here that's going to just change with your score count. Form for submits, input for reading the user's input, the modal that we're going to show and hide. Clue text is the name that we need to dynamically plop in the clue text, and then just a few other things here, mostly just for showing and hiding purposes. Now all these lines start with element, and that element is referring to the element that was passed in here. So we are expecting that inside that element we have a board class, a score count class, etc., all these things. And that is the HTML that we walked through at the beginning of the video. And so this is nice though, because say you wanted to have multiple instances of the quiz game, you could. It would just be a matter of having multiple of these containers on the page. I don't know why you'd want that, but if you wanted that, you've got the flexibility. And with that, I think our constructor is good. Alrighty, let's start building out some functionality to this thing. First thing we want to do is make our first method called initGame. And what this is going to do is actually be like its own event for us starting the game whenever we want, rather than starting it right after the constructor runs. Don't want that. Sometimes it's nice to keep that as its own separate event. And the first thing we want the game to do when it starts is just to render the first score to the scene here. That's going to be a 0. And so what we can do is grab this score count element that we cached up here. This .score count element .text content equals to whatever this .score is. And we're not actually calling this method yet, so what we want to do is down here, after we create our game, we're going to say game.initGame. Now that that's run, you can see that the number 0 is appearing here. And what I'm going to do is kind of actually break this out into its own method, because we're going to be updating this a few different times, a lot actually, whenever you score some points. And so let's just make our own method called updateScore. And that's where this is going to go. We can move this inside here to updateScore. But sometimes we're actually going to want to change the count of the score. We need a nice place to do that. And so let's just do that here. So in here, we can pass in change and say this.scores plus equal change. And then when we call this updateScore, we can just change it with 0 for now. Now we're set up for later, because when we score, say 100 points, we just call updateScore, passing in 100. Our score state will update, and then our DOM will update as well. Now this isn't very exciting so far, so let's get into the fun stuff. Now we want to start fetching our categories. This is kind of the meat of the game here. So inside initGame, right after we update the score to 0, I'm going to run a new method called fetchCategories. And here, this doesn't exist yet, so we'll come down here and define it. Scrolling us down here. fetchCategories. And what we need to do now is go out to that API, and for every category that we have that we want to use in the game, we need to go fetch all the clues that belong to that category. Now, unfortunately, this particular API doesn't give us the ability to batch request categories. We kind of have to get them one at a time. And so that's a bummer, because we're making multiple network requests. Typically, you want to squash those into as few as possible, both for client-side performance and for not hammering your API too hard with many requests. But we're just going to roll with it. So I'm going to paste in some code here and walk through it. What I've done is create a new variable called categories. And this is going to use that array of IDs that we passed in up here. So we're using our default video games through the line, those IDs that go into the API for the category. And for each one of those, we're going to translate it or transform it into a promise. And so this promise is going to do a fetch going out to the JService API, passing in the category ID. So we have JService API. Remember, this is just one of the endpoints you can use with the API. And from there, we're just going to do our typical fetch stuff, where we get a response, we turn the response into JSON data, and then we have our data to work with. Here, I'm just logging it out so we can see it. So let me pop open my console here and see that we have 4. Just want to make sure you can see that. We have 4 that came back, and within each one, we have an array of clues, clue count, ID. Remember, this will match up with the ID that we passed in, and then a title. We have this for each one of the categories that we passed in. And if I open one of these clues up, you see that each clue has an ID. It's got an answer, a question, and a value. So when that's all done, we can take our promise that we've created and finally resolve it. And so after this loop where we're creating, all these category promises, we can say promise.all and then pass in our categories. And then from then, we'll get a data array back. So we'll say .then, when all those are done, we'll get some results back. And these are going to be exactly what we just looked at in the console. From here, we can start building out our database that we defined up here in the constructor. Here's the data structure we're going for in this app. See, I've got 2 different things at play here, categories and clues. Categories is going to be an array. And within the array, we're going to have objects. And each object's going to have a title and then a list of clues. But instead of having all the data of the clue be in here in the categories, we're just going to use a unique key. And that key is going to correspond to our clues data set over here. So in here, we just have IDs of clues. But then when we want to look up that clue, we come over here to our clues object, where you see we have the same key. Inside here, we have question, answer, and value for each clue. This is nice because there's only one central spot where we look up clues from. And maybe it's a little bit of overkill for this simple of an app, but as things grow, games, applications grow, this kind of flat data structure can be a really nice pattern to work with. Alrighty, so back in the code, I'm going to get rid of this console log. And then here, let's go ahead and construct that data set that we talked about. So in here, I'm going to loop through all the results that we got. So results.forEach, and that's going to give us a category and a category index. And this category index is what we're going to use to be part of that unique ID for each clue that we'll construct. Here I'll say var new category, like a new one we're going to add to our list, is going to have that same structure where we have a title, and this is going to be a string, and that string is going to come from this category that we pulled from the API. So it's going to be category.title, if you remember what we saw in the data. And then we'll go ahead and just start with an empty array of clues. Now currently we're getting back every single clue that's ever been asked in this category from the API, and that's a little bit more than what we need. We only need 5 of them. And then furthermore, we don't want them nested in the category like they're coming out of the box. What we want to do is kind of break them out into their own data set like we talked about in that diagram. So what I'll do is say var clues equals, go ahead and gonna shuffle the clues that we get back. So the result.clues, and then just bring that down to 5 of them. So we can do .splice 0 to 5. That'll cut it down to only a list of 5. And then for each of these, this is going to be a clue and then another index that we have. We can go ahead and create that unique ID. So clue ID is going to be category index from up here plus a dash plus this index. And so this is like Super Mario Brothers style. It'll be like 0, 1, world 2, 1, 2, 3, 2, 4. It doesn't really matter. It just needs to be super unique. And so this will do the trick. Now we're going to push a reference to this clue into our category clues array. So here we can say new category dot clues dot push this clue ID. So now we have a reference to it, but it isn't really here yet. It doesn't exist in our clues object. So we'll say our clues object, the key that we created, is going to equal a new object. And here's where we're going to copy over all that data that's coming back from the API. So question is going to be clue.question, answer, and value. Now, for the sake of this tutorial, we're not actually going to use the value that's associated with the real world clue. That would involve way more logic on sorting and finding clues. If we need 100, 200, 300, 400, and 500, that we have all of them. That's a little bit more complex than what I wanted to go for in this video. So instead, we're just going to use the index plus 1. So that'll be like, if it's the 0th one in the index, and we add 1 to it, that gives us 1, and then we'll times it by 100. So that will give us 100, 200, 300, 400, and 500. If you want, a good enhancement to this project would be to actually use the value coming back from the actual clue. And then finally, when all this is done, giving us more room, we can push our new category into our global list of categories. So this dot categories dot push our new category. And whoops, I used the word result here. I should have used category. Okay, and then finally, when I'm done with all this work, I'm going to go ahead and just console.log out this, the class, so we can see how all this data structure stuff landed. So I'll pop open the console. Here's our trivia game show class. I'll zoom in and see that we have a flat list of clues, just like what we wanted. Key value pairs, they're all unique. And then a list of categories. And so we've got our video games, 3-letter animals, geography, the same stuff that we passed in before, what we expected. And we get an array of clues, each one linking up to our key value pair of clues in our class. Okay, so all of our data is finally figured out. Now let's actually print something to the screen so we can see it. So we'll say this dot categories, for each one of the categories that we created, dot for each category, we're gonna this dot render category, which is a new method we haven't created yet. We'll do that next. Let me clean this up just a tiny bit here to make it easier to read. Okay, creating a new render category method. And what this is gonna do is take in a category and then print something to the screen for it. And so what we need to do is start creating DOM elements that we're gonna inject into the board. So we'll say one of the columns is gonna be document dot, create element. We'll start as a div, and then we've got some styles ready to go for this div. So we'll say column dot class list dot add column. So this is gonna create a div in memory, and then in that memory div, it's gonna add a column class. And now let's start filling it with some HTML. So we'll say column dot inner HTML equals, and a cool way to do this is ES6 string templating. So you get your backticks going, and then you can kind of inject data in there. So we'll start with a header. And this category, again, it's coming from our categories in that data set we just looked at. So we know it has a title. So with my $ curly braces, I can say category.title. And then I know we're also going to want under here, let's see, how should we do this? A new UL, an unordered list. And then in this unordered list, we're going to start filling in those categories. Just to see it working so far, let's go ahead and say this dot board element dot append child. We're going to finally append something to the DOM, and that's going to be our column div. Let's just see what happens. And hey, here we go. Look, we've got stuff on the screen. So for each category, we've rendered out a header tag with just the text in it. But now let's go ahead and start adding some of those the clue buttons. And so under here, even though this UL is like only in memory at this point, we can still select it. So I'll say the UL is going to be column.query selector UL. And so that's digging into this column that we've created in memory and just getting the UL out of it. And then for each clue that we have, remember we've got that array of clue IDs in each category. We're going to say for each clue ID, the clue that we're talking about is the one in this dot clues with this ID. So when this runs, it's going to be one of those objects that has answer, question, value. And then finally, this UL, the inner HTML, what we can do is say plus equals to add to it a new li, in our UL. But in that li, we also want a button. And we see the styles coming in already. We've got blank, blank li, blank button. The button's text should be clue.value. Nice. So now we see our numbers coming in. And then finally, we need something on this button to tell our click handler that we haven't set it up yet, but we need something to tell us which button we clicked on. And so to do that, I'm going to use a data attribute. So data clue ID equals, same thing. We're just going to include the clue ID here. So now when I inspect each button, if I pull it up here in Inspector and zoom in, you can see that data clue ID is the unique ID assigned to each clue button. So you have 0001. Every button on the screen here has a unique clue ID. Great, so we have buttons, but they don't do anything when you click them. So let's fix that. New method, let's say handle clue click. It's a tongue twister, if I've ever heard one. And that's gonna take in a click event that we'll set up in a second here, but here we'll just say that the button will alert when it's been clicked. And then up here, when we init the game, that's when we're going to go ahead and actually start binding DOM events to happen. And so what we're going to do is say this dot board element, which is the parent board element, dot add event listener, click, and then we get the click event back. If the one that was clicked on has dataset.clue ID, meaning the element that was clicked has a data attribute on it called clue ID, then we know that this was a button click. And so we can say this dot handle button click, passing in that same event. So this is called event delegation, where we have a click listener that's technically ready to go before these buttons have even arrived, because this init game will happen right when we start the app. Fetch is technically happening first, but there's no way it's going to finish before this happens. So this is nice. As buttons enter and leave the DOM, we can still be listening for clicks on them. And now when I click the button, see that an alert pops up saying I've been clicked, meaning the binding is all wired up fine. But that alert is very boring, not very beautiful. So let's go in and inside this handle clue click method, I'm going to go ahead and just paste in some DOM manipulations to happen, and we'll walk through them one by one. So the first thing that happens when we run this click event, we're going to go ahead and look up the clue based on the data attribute that we clicked on. So that's going to correspond to one of those objects in our clue data set, the thing that has value, question, and answer. The next thing we're going to do is mark that button with a new class called used. And what that's going to do is actually hide the button using CSS, but preserve the LI. So the LI will still be there for spacing reasons, but there won't be a button to click anymore because that clue has already been clicked on, already been activated. Now, peeking back at our HTML for a second before we go any further, if I open this up and look, what this click is going to do is start to reveal this card modal part. And inside that we have the form and then, the text bits that tell us the question and maybe reveal the answer and all that. And so this JavaScript that we're looking at is about to kind of clean house and get ready for that to happen. So the first thing we're going to do is take the text input inside that form and clear it out in case this isn't the first time we've interacted with it. Next, we're going to set that current clue variable to the clue that we're working with now. And so we're going to use that to pull the question and answer and populate the text nodes inside that modal. So clue text element, that's what the question is, and then the result, what the answer is. Even though that starts hidden, the text is going to be populated from here. Next, we're going to hide the results. So again, in case this modal's been open before, we're going to make sure that the answer part is not showing. And then finally, we can reveal the modal. So to do that, we just add the CSS class visible on it, and then we'll go ahead and automatically focus on the text input so that the user doesn't have to click it to start typing the answer. So let's go ahead and try this out. I'll take video games for 100, click it. Our modal appears, it's got a CSS transition on it. And we get our text, Spellcasters and Adventures. I know this. This is, it's got a tiger on the cover. EverQuest, right? EverQuest. Yes, so now I can type it in and click answer, but we haven't set up the form submit yet. Alrighty, so let's set up the form submit so we can actually play the game. What I'll do is go ahead and add another method right under our click handler. This is going to be called handle form submit. And what this is going to do is take in the raw DOM event for submitting the form. And we want to first just, give us more room here. First, just make sure that doesn't happen to cause an actual reload. So we'll control this form submit with JavaScript entirely. Next, we want to do is figure out if we have a correct answer or not. And so we'll say is correct is going to equal this dot input element dot value. So whatever we typed in, does it equal exactly this dot current clue dot answer? And so here we have just a simple string compare happening. This will technically work, but it's a little bit error prone because if you type in anything that's a little bit different, like maybe an extra space or an extra character or something, even though the root answer that was provided is correct, the strings have to match exactly. So we're going to revisit this in a second to kind of make that more robust. But until then, we'll say if it's correct, we're going to go ahead and update the score to be whatever the current clue's value is. So if I click on 300 and launch the modal and I answer the question right, it should give me 300 points. Finally, after we submit, we're going to go ahead and just show the answer. And so to do that, we need another few DOM manipulations similar to what we did here. And we'll keep those in a new method called reveal answer. And we'll go ahead and pass in if we were correct or not to this method. Here's what our reveal answer code is going to look like. I'll just paste it in. So reveal answer, again, it takes in if we're correct or not. What we're going to do is take the success and the fail text element and only display one of them. So if is correct is true, then we're going to go ahead and set block on the success element, otherwise none, and then we'll do the opposite with the fail element. So if is correct is false, then we'll go ahead and set block on the fail element, otherwise none. Next, we'll bring in the CSS rule that actually reveals those text nodes. So showing result, again, peeking at the HTML, that is this container right here. So first, before you submit anything, you only see the form. But then once you submit something, we'll be adding a class onto the modal, which is this up here. And that's going to trigger some CSS to then hide the form and only show the result part. Right before we did that, we toggle on either the fail paragraph or the correct paragraph. Coming down here, after a short delay, so you can see what happened, we'll go ahead and remove visible from the modal class like we talked before. So that will give us back to the board view. And we'll do that just after a little delay. I have 3 seconds here. Now we have these functions ready to go, but we're not actually using them yet. So what we need to do is bind events, just like we did with the click handler. So I'll come back up here. I'm going to add this dot form element. We're going to add an event listener. This time we're going to listen for a submit event. And we can just pass that straight through. And now when the form is submitted, our handler will fire and we can actually play the game. So now when I click on a question, I get the chance to do some input and I can type some stuff in here, submit the form, and then it'll validate the answer and show me what was expected. Now let's go ahead and address the problem we have down here, where if is correct is currently an exact string match for the input's value and the current clue's answer string. But I gotta tell you, this API has some stuff in it, some kind of weird data where sometimes the expected answer is wrapped in an I tag. Sometimes there's like an owl instead of just owl, or weird characters here and there. And so what we need to do is just like a little bit of a friendly cleanse for both of these values so that we can actually judge the intent of the answer. So I'm going to create one last method here, and let's see, we'll put it right here. We're going to call it cleanse answer, and that's going to take in an input string. And so what we're going to do is add in some operations here to clean up the string input so that we can more easily compare two different strings. So I'm just going to paste these in here, and we'll just talk through it line by line. First, we're going to create a new variable called friendly answer, and that's going to be our input, but we're going to lowercase everything. So taking out any capital letters, don't care about those. Next, like I said before, there's sometimes some I tags. So we're going to rip out the opening and closing I tags from friendly answer, take those out. Then we're going to take any space in the string and remove that as well. So Donkey Kong will become Donkey Kong, just one lowercase string. Same with a and an here. So say if the expected answer is a porcupine, but we only typed porcupine, that should be good enough. And so we're going to just take a and an out of there. Same with an. And then finally, we're going to trim out any extra white space, which we probably don't need this because of this line, but that's okay. You could achieve this in all, like in one nice regular expression. I thought listing it out one by one like this is a little bit easier to read for the tutorial's sake. And that said, there's definitely going to be more edge cases here. So that would be another good enhancement opportunity for this project, is to make this cleanse answer thing a little bit more robust. Now let's go ahead and use this method. So in is correct, what we want to do is run both of these strings through that same method to make them a little bit nicer to compare. So we'll say this.cleanse answer first with the input value, and then this.cleanse answer with the expected answer. And now each string will go through its own little conversion process, thus making the comparison a little bit more fair. Okay, let's try this out. So I'm going to open this up, choose a video game one. How about video games for 300? Donkey Kong Land on the new Pocket version of Portable. Right, so that's Game Boy. So if I submit that, correct. Now that I've submitted the correct answer, you should see that my score is up to 300. And this option is no longer available. Now we can continue to play the game and see how much we know about all these different things. All right, everybody, that wraps up the scope of this video. Of course, there's a lot more we could do here. For example, this is Jeopardy. We completely ignored the answering as a question thing, like what is an owl versus owl. That would be a potential enhancement you could add to this. You could also add multiplayer if you wanted to play this with a friend and have the whose turn is it kind of flip back and forth. You could have random categories. Instead of providing an array yourself, it could just pick random ones. The sky's the limit here, really. If you like this video, I really appreciate it when you hit that like button. And again, if you're interested in game dev JavaScript tutorial content, please subscribe to the channel. And hey, if you're working on an indie game right now, we have a Discord channel with people making and playing indie games. So if you're interested in that, join us. It's in the description below. Alrighty, thanks so much, everybody. Catch you next time.